All right, good morning, class. This is Mr. Sadler coming to you live from the internet. It is Wednesday, April the 29th. I hope I got my days right. And today we're going to do a few more word problems. Before we begin, I would like you for a warm-up to solve this equation. We're going to solve 8x squared plus 5x minus 3 equals 2x squared plus x plus 5. Okay, so if the supply teacher could please hit pause in the video, and we'll take it from there. All right, good. Here comes the solution. I'm going to start first with Lindsay again. Lindsay, can you tell me how to solve a quadratic like this? What's the first step? No, coughing as loud as you can is incorrect. What we're going to do exactly is move everything from the right-hand side to the left. So it's going to go 8x squared minus 2x squared plus 5x minus x minus 3 minus 5, and that's going to equal 0. Remember, whenever there's a quadratic that we have to solve, you have to make it equal 0. All right, Noah Solinger, keep going, please. What's 8x squared minus 2x squared? Good, 6x squared. 5x minus x is plus 4x. And negative 3, negative 5 is negative 8. I'm going to take out a common factor, I think. Spencer, what can 6x squared, 4x, and negative 8 all be divided by? Good, they can all be divided by 2. So I'm going to call that 3x squared plus 2x minus 4. It's just a little bit smaller equation, so it's a little bit nicer to work with. I don't think we can do solve this by factoring, so we're going to use the quad formula for this. All right, Maya, can you recite from memory what the quadratic formula is? Awesome. Now you can either use the 6, the 4, and the negative 8, or the 3, the 2, and the negative 4 will give you the same answer. I'm going to use the 3, the 2, and the negative 4. Okay, so we're going to have A equals 3, B equals 2, and C equals negative 4. All right, Jenna, can you please sub in some numbers, please? Okay, good. So x is negative 2 plus or minus the square root of 2 squared minus 4 times 3 times negative 4 all over 2 times 3. Okay, great. All right, Alyssa, can you tell me what 2 squared is, please? Good, and then negative 4 times 3 times negative 4. That should hopefully be positive 48. Over 6, that changes to x equals negative 2 plus the square root of 52 over 6, or x equals negative 2 minus the square root of 52 over 6. Okay, if you're Alistair and you're sitting in the middle of the class, hopefully Alistair, you are sitting in the middle of the class, not in the back row. You'll say to yourself, well, Mr. Sadler, I used the 6x squared plus 4x minus 8, and I got a different answer. Hopefully when you do the calculations here, you'll get exactly the same answer. So I'm going to go to my, oops, maybe not. I meant to go to my calculator. There we go. And I'm just going to find out what the square root of 52 is. So I'm going to 52 square root, and I get 7.2111, which just makes it easy. So x is negative 2 plus 7.2111. All over 6. Or x equals negative 2 minus 7.2 all over 6. All right, so when I do this in my calculator, I'm going to say 2, sorry, I have to close that, sorry. Oh goodness. Okay. I'm going to open up my calculator again, sorry about that. While I'm doing my calculator problems, You guys should be able to calculate that for me on your own calculator. I'm going to do that as 52 square root minus 2 equals divided by 6, and I got 0.87 for the first one. Okay, on the right hand side, I'm going to do that 52 square root plus minus and minus 2. Change to that, divide by 6, and you should get negative 1.25. Okay, so the intention of this warm-up was to get you guys used to using the quadratic formula and factoring and solving equations. For yesterday's word problems, if you remember, we used maximizing. Today we're going to be solving. We'll be asking when or what or how, and when you do that, you're going to actually solve the equation. So today, today's question is called geometry word problems. Okay, I'm going to make a few rules for solving word problems, and if you want to write this down, this would be lovely. Okay, so suggestions are going to be, and this is what I've always done as a student, and as you can probably guess, I ended up being pretty good at math because I always tried to do this every single time. My first suggestion is read the question twice. Because what will happen is if you just skim over it, you'll miss things. Every test, somebody raises their hand and they'll say, what am I looking for? Or I missed that, or I didn't see that. Read the entire question all the way through twice. Once you're done reading the entire thing twice, you're going to read the last sentence again. All right, Cassidy, why is it that I might want to read the last sentence again? What information will that normally give me? Good, so that's normally going to give me what we are looking for. You will never find a math problem, a math word problem, where they say, what color, how high does the basketball go, and then they give you all the information after. Like the last sentence will be that. Number 3 will be draw a diagram. These are geometry word problems, so these questions will involve rectangles and circles and triangles and all that stuff. So draw a picture, it really helps to do out. Number 4, declare your variables. And 5 says, ask, does this make sense? Now, haha, I know it's math class, so the answer will be no. Okay, but when you're working on a word problem, when you're setting it up, does your picture logical to how it should be? Okay, is your variables look like they're going to make sense? Is your equation set up balanced the way it should be? Those are the things you should ask yourself as you're going through. Okay, so here we go, example 1. What we're going to do today is I'm going to do one example for you. The next 2 examples you're going to do yourselves, and I'll take up the solutions, and then we'll have some homework at the end of the day. So example 1 is going to say, Hannah has a 20-meter by 30-meter pool at her house. There is an equal strip of pavement around the pool whose area is equal to the area of the pool. Find the width of the pavement. Find the width of the pavement. Okay, so Mr. Tozer or whoever else is in there, if it's not Mr. Tozer, hit pause on the video for a second, give the kids a chance to scribble that down, and we'll start to take it up here in a second. Alright, so I'll write my solution beginning on this board. So hopefully you've all read through the question twice, and then you read the last sentence a third time. Alright, Leo, can you please read the last sentence out nice and loud? Okay, good. Find the width of the pavement. So Liam, what are we looking for in this question? Okay, good. It's the width of the pavement. So as soon as I see that, I'm going to say let x equals the width of the pavement. Okay, so I've done my x is going to be the width of the pavement. Life is good. I'm going to draw a picture. Okay, so the first picture is, this is Hannah's house here. Here's a lovely house with a 20 by 30 pool. So there's the water. I should probably color that blue. Okay, so there we are in our 20 by 30 pool. What this question is actually asking, excuse me as I color. Give me a minute of amusement, please. Okay, so there's the pool in the middle, all right? What this question is saying is that we're going to have a strip of concrete all the way around. Okay? And it's going to be the same distance. So what I'm going to say here is that I'm going to call this distance x. 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 Okay. So next up is finding out actually how we're going to solve this question. So what we're trying to say is that the area of the concrete is equal to the area of the pool. All right, Lexi, I'm going to pick on you. What's the area of a rectangle, please? Length times width, lovely. So let's do the area of the pool first. What's the area of the pool going to be? 20 times 30. The area of the concrete is going to be a little bit more complicated. Okay. Going back to composite shapes from grade 9, Emily, all I basically want to have is this thing I wrote to circle in red. I was trying to point to that, but you guys can't see me pointing. Okay. Is this thing around here? That's what we're looking for. Okay, we're going to punch out the middle. So I'm going to call the area of my concrete to be the area of the big square, big rectangle, minus your pool. Okay. Okay, now here comes the tricky part. I have to get this distance from here to here, and this distance from here to here. Okay, I'm going to get somebody to raise their hand to volunteer, and Mr. Tozer will say their name. Okay, thank you. If that person can try and tell me what this distance is. Very good, wow. I'm going to call that 2x plus 30. Now let's see why that is, okay? I'll do this in green to hopefully show it. That distance right there is going to be x. That distance right there is going to be x. And this distance in the middle here is going to be 30. So the entire distance altogether is 2x plus 30. Okay, Emily, since you've had some help, I'd like you now to try the top left distance. It's going to be what then? So I'll help you here. This distance from there to there is going to be x. From there to there is going to be x. And that should hopefully be 20. So my total distance is going to be? Okay, good. So 2x plus 20. So the area of the big rectangle I'm going to say is 2x plus 30 times 2x plus 20. Next it says I have to subtract the area of the pool. Well, you're in luck, I know the area of the pool already. So it's going to be minus 20 times 30 equals 20 times 30. Now I'm going to hit pause on the video for a second, let you guys solve this. If there are any questions on where this came from, Mr. Tozer, this will be your time to shine right now. Okay, to try and explain this one. I'm going to hit pause on the video right now. All right, so let's try and take up the solution right now. We are going to solve for x in this case. The keyword that told us to do that, number one, it says find the width. So that's like solve, which means quad formula. Also because right here there's an equal sign. So when there's an equal sign, that means like we're going to have to solve something. All right, I don't think that Natalie's here today, but I'm going to assume that you pretend that you are here right now, so you can show off your foiling. Okay, so let's FOIL out, please. 2x times 2x is 4x squared, good. 2x times 20 is plus 40x. 2x times 30 is plus 60x. 20 times 30 is 600. 20 times 30 is 600. That equals 600. There are a lot of 600s there. All right, Desiree, can you neaten up the left-hand side for me, please? Good. 4x squared plus 100x equals 600. Great, tremendous, wonderful, awesome. All right. Karina, when there's a quadratic like this, how do we solve it? Is it possible to solve? Well, of course it's possible to solve. All right, we have to make it equal 0. So it's going to be 4x squared plus 100x minus 600 equals 0. Okay, first step to solving this one is always what? Like, it looks like to me I'm going to take out a common factor of 4, so I'm going to divide this entire thing by 4. I'm going to x squared plus 25x minus, what is that, 150? Equals 0. So we're looking for something that multiplies to get negative 150 and adds to get 25. I'm going to call that 30 and negative 5. Okay. So what's going to happen is I'm going to write that as x squared. And by the way, if you like the quadratic formula, you may certainly use it. I'm not going to stop you, but I'm going to factor this because I want to. Little dotted line goes down in the middle. There's an x on the left, and x plus 30 minus 5 and x plus 30 equals 0. And that's going to change into x minus 5 and x plus 30 equals 0. Therefore, x equals 5 or x equals negative 30. Okay, Calvin, what's my length? What's the width of the pavement going to be? It's going to be 5. Negative 30 is out. What a negative 30 width would be, instead of moving positive to the right this way, we'd just be making our width all the way over the opposite side of the pool, which is no good. So we'll then end up and say, therefore, the width of the pavement is 5 meters. And that's a very cool question. Hint, hint, nudge, nudge, wink, wink. Okay, I'm going to hit pause in the video for you guys right now. If there is something that you need to ask Mr. Tozer, because he is a pro at math, okay, please be brave and ask him right now. Okay, because I got 2 more examples like this coming up, and you have to feel good about that. Okay, here we go. Example 2 says, how about we say Dairy Queen, since everyone works at Dairy Queen, has a store that is 25 meters by 35 meters. If their parking lot evenly has even width around the building. And is 900 meters square. Find the width of the pavement. Okay, this question is very similar to the last one. All right, I'll start with Bailey, who's not here, but I'm going to assume that she is. Bailey, what's my unknown going to be in this case? Sorry, I should say, teacher, please hit pause. All right, good, good. Go ahead, Bailey, what's my unknown going to be? Width of the pavement. Solution. Let x equals the width of the pavement. Okay, I would like everyone in the class right now to draw a diagram and try and make an equation before we start, okay? The diagram's the first key one, and then the second. I'd like to hit pause, please, teacher, and try it. Let's give the class a chance to try right now. Okay, and now we're back. In the middle is going to be the DQ store, which I wish I had a cool logo, but I don't. So there's a 25, there's a 35, and I don't know what DQ logo looks like. I'll just say DQ. I don't know what it looks like. Okay, all the way around the store, there's a parking lot that looks something like this. And the distance all the way around is going to be x. All right, Luke, what is this green distance on the bottom going to be, please? Very good. So that's going to be 2x plus 35. Wonderful. All right, Emily Moser, what is this distance on the right going to be, please? Okay, good. So it's going to be 2x plus 25. Okay, I'd like you to raise your hand if you did not get that or don't understand where it's coming from. And Mr. Tozer will hit pause and explain, hopefully. Okay, good. Okay, so we're going to say in this case the area of the pavement should equal 900 meters squared. Okay. So the area of the pavement is going to be the area of the big rectangle minus the area of DQ equals 900. So it's like you take a little punch and destroy that little DQ symbol in the middle. The area of the big rectangle should be 2x plus 35, 2x plus 25. The area of DQ should just be 25 times 35, and that should equal 900. Now, once I have this equation set up, instantly you're not going to you're not going to complete the square because nowhere in this question does it say maximum or minimum. Okay? If it is not a maximum or minimum question, you're going to be solving. This one I think will end up being quad formula, but we'll find out in a sec. All right, Jasmine, can you FOIL out the left-hand side for me, please? 2x times 2x is? Good. 4x squared. 2x times 25 is? Good. 50x. 35 times 2x is? Good. 70x. 35 times 25, I don't know off the top of my head. Oops. The calculator. That's okay. 35 times 25, and of course, Jasmine yelling out this answer, which was 875. And minus 875 equals 900. Okay. Good. All right, Alistair, can you neaten that up for me, please? So we have 4x squared plus 120x equals 900. We have to factor this or quad form this, so we will be looking at, excuse me, minus 900 equals 0. I'm going to divide by 4, and hopefully that will work. Okay, so I'm going to divide everything by 4. I'm going to divide that by 4, which is still 0. So I'm going to have x squared plus 30x minus, I want to say 225. Check from really late when I'm going down. It's 900 divided by 4 is 225. Good. Okay, so next, you can factor this if you can. It's going to be pretty hard to find the number, so I'm going to use quad formula for this. So I'm going to say x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, Jessica, can you give me A and B and C, please? Great. A is 1, B is 30, C is negative 225. Noah, can you sub some numbers in, please? Good. Negative 30 plus or minus the square root of 30 squared minus 4 times 1 times negative 225 all over 2 times 1. So that's going to be negative 30 plus or minus the square root of 900 plus 900 all over 2. So x equals negative 30 plus the square root of 1800 all over 2, or x equals negative 30 minus the square root of 1800 over 2. Now, Caleb, I have a lot of confidence in you right now. Can you please give me those answers to 2 decimal places? While he's thinking about that, I'm going to type it in myself. So 1800 square root is going to be that. Minus 30 divided by 2. I get x equals 6.21. On the right side, it's going to be negative, so it'll be invalid, but I'll still figure it out anyway. So 1800 square root plus minus minus 30 divided by 2, and you get negative 36.21. Therefore, the width of the Dairy Queen's parking width is 6.21 meters. Okay. All right, so the time here. Okay, I think we have time for one more example here. It's 28 minutes. I think we have time for one more, hopefully. Example 3 is going to be another nice one. It's going to say, we'll say Mr. Sadler has a clock with radius, we'll say 10 centimeters. If I wish to paint the border with, we'll say, 250 centimeters square of paint, how wide can the border be? Okay, I'm going to ask the teacher to hit pause and give the class a few minutes to try this on their own. You guys can do this, all right? The difference is instead of using a rectangle, we're using a circle. If you need to know the area of a circle, the area of a circle is pi r squared. All right, here we go. Derek, can you tell me please what x will be in this case? good. So let x equals the border width. Let's get a diagram drawn out. So here's a beautiful clock of Mr. Sadler's. There's 12, there's 3, there's 6, there's 9. What we know is that the radius is going to be 10 centimeters. Okay. What we also know is that I'm going to put a nice border around my clock, sort of like this. Okay. The distance all the way around is going to be x for that. Okay, so we're going to say the painted area is going to equal, we said 250 centimeters squared. So it's going to be the, to get the painted area, it's going to be the area of the red circle minus the area of the blue circle. Is going to be 250 centimeters squared. Okay, so to get the area of the red, we got to find the distance, which I'm doing green, this entire distance from there to there. If this part is x and that part is 10, altogether that's going to be, okay, good, that's x plus 10. So we're going to do the area of this is pi x plus 10 squared. The area of the blue then is going to be minus pi times 10 squared, which will equal 250. Okay, here we go. So let's keep foiling out here. So I'm going to do this as pi times x plus 10 times x plus 10 minus pi times 100 equals 250. Fold it out, and I'll leave that pi in on the outside if I can. So pi times x squared plus 10x plus 10x plus 100 minus 100 pi equals 250. I'm going to try and stay away from calling that 3.14 if I can for as long as possible. So when I expand all that out, you're going to get pi x squared plus 20 pi x plus 100 pi minus 100 pi equals 250. And simplifying, you'll get then pi x squared plus 20 pi x minus 250 equals 0. All right, so now you can switch to 3.14 if you want to. Now again, we're rounding a little bit here for pi, so our answer is going to be off by a little bit. And now we just solve by quad formula. So I'll do this very, very quickly. So x is going to be negative 62.8 plus or minus the square root of 62.8 squared minus 4, 3.14, negative 250. And by the way, Mr. Tozer, if you need to pause it anywhere here and explain, feel free. So it's going to be negative 62.8 plus or minus the square root of, whoops, wrong one. 62.8 squared is 3943.84 plus 4 times 3.4 times 250, 3140. All over 6.28. So that equals negative 62.8 plus or minus the square root of 7,003. I'm not sure what it is. Try again. 3943.84 plus 3140 is 7,083.84 cents. All over 6.28. I'm just going to extend the page here for a change. want to finish this if I can. And that then equals square root that, and then we will subtract 62.8 equals divided by 6.28 equals 3.4, 0. Or x equals square root plus minus 62 equals minus negative 23.4. Once again, we're going to scratch this one. Therefore, the border should be 3.40 centimeters. Okay, if you're thoroughly confused by that last one, that's okay. We'll work through it for that. I want to make sure you can handle the first two, because those are the ones that I consider to be a little bit more important on that. So your homework tonight is going to be page 358. Number 7, 11, and 16, and page 362, number 16 and 17. Okay, so the plan for tomorrow is going to be, I don't think I want to leave you a video for tomorrow. That may change, but I'm planning right now to give you just a worksheet of homework questions that you can do in class. It'll be all through the unit. It's not a choice assignment, but it's, and I'm not going to collect it, but it's meant to be a sheet to keep you up on the swing of things when I'm gone there. So give a good effort with this tonight. You'll have more practice tomorrow, okay, on this for sure. And the same thing also with the max min problems from Tuesday. All right, thanks everybody. Have a good day. I'll see you on Friday.